So we have already seen the calculation of prefix function in the previous video. So those who have not watched that video, please watch that video first. So now we will be starting with KMP Matcher. So what is a KMP Matcher? So we will see with an example. So here the string size is 15 and the pattern that we want to match is 7, right? So now we are starting from the counter I for the string from the first position. So where is the first position? This B is in the first position and Q is at the 0th position. So here Q is there, which is at the 0th position. So what we have to do is we have to compare with Q plus 1 value. So B and A is compared, so it doesn't matches. So in that case, E, that is a pattern which shift one position to the right. So here now A is compared with the string A. So here P is shifted when it is not matching, right? So A and B was not matching. So in that case what we have done is we have incremented S also and we have shifted P. So P is starting from 1 only, but we are just simply shifting P, right? So now A, that is here after 0, it is Q plus 1. We have to compare Q plus 1 with the value of the string, that is second. So is it matching? There is a match. It is matching. So we will be shifting P to the next position, that is we are incrementing now. So now after the second step, what we have to do next? So next we have to compare the next pattern with the next string. So here the string is also incremented and the pattern that is compared was the second one because the first one we have already compared. So here the Q value is 1, so we have to compare with Q plus 1, so that is 2. So here what we have seen is it is not matching B and C. Now in the time when it is not matching, we have to do backtracking on P. So backtracking on P, so for that what is required? Here this B and C is not matching, right? So in that case we will look for the prefix function of B. So the prefix function of B is 0. So we will again move back the pattern to the 0th position. So we will not backtrack the string, but we will backtrack the pattern. So we will see the next step. So after backtracking, what happened is the Q value will become 0 at the next step. String is keep on incrementing. It's now incremented to the 4th position. We will compare the B with A. So again it's not matching. So in that case, if it is not matching, so again backtrack. So again we move to the 0th position. So 0th position we move and we move the string to the next one. So now we are comparing A with A. Is it matching? Yes, it's matching. Now we increment it once more. So is it matching? Yes, it's matching. So we will see what happened in the next case. So now A is matching, B is matching. So the next one is we have to simply increment the string as well as the pattern. So here now the pattern is on 8th position. Now A is also matching, B is also matching. So we keep on incrementing and checking. Once the previous patterns are matching, so we'll see the next one. So here what we are doing is next we are comparing A with A. So that is also matching. Then we compare B with C. Now it is a mismatch. So we have to what we have to do is our position for q we have to first check. So what is the value for q? Q is at the fifth position. So 1, 2, 3, 4 and 5. So what we have to do is the fifth position we have to check the function value. So prefix function value is 3. So in that case what we will be doing is we will be moving to that specific place. So we can move to the previous diagram. So where 3 is there, that is the fifth position, the value is 3, right? So what we have to do is next we will be backtracking from that position. I will first rub it. So we were in the next step. So here there is a mismatch. So in the step 10 we can see that there is a mismatch between B and C. So in that case the value of Q will be 3, right? So now what we have to do is we have to take Q equals to 4. So we'll be starting from 4 because the previous value is 3. So we will be finding out from the fourth position. So 4 plus 1 is A. So here AA is matching. Then what we are doing is we are matching P5 with S11. We keep on incrementing S. S comes out on the 12th position. So we will move to the 12th position. So what will happen? We will compare with the next pattern. CC is matching. Then we move to the next one. Again next one is matching. So here what the pattern P that occur in string S. So how many shift took place for that? So I is 13. So the iteration number is 13 and the length of the pattern is 7. So 13 minus 7, how many shifts required? 6 shifts. So now we will move to the KMP Matcher. So we will see the algorithm now. See in the algorithm what we are doing is first we are finding out the length of the string. So suppose the length of the string is 15 and the length of the pattern is 7. Then we compute the prefix function for all the values that are there in the pattern. We create a table for that. Then we set number of characters that we are matching. So we are starting from 0 because initially we are not matching anything. So the pattern starts from the 0th position. So after that we keep on incrementing the string from 1 to n. We keep on scanning from 1 to n. We check whether q is greater than 0. If yes, then q plus 1 is not equals to s of I. So if it is not equal, in that case what we need to do is, in that case if q is not equal, q plus 1 is not equals to s of I, the string 1. 1 1 is not matching, so in that case we will be checking out the prefix function, right? So if it is not matching, we will check out the prefix function of q, and then based on that we will be doing the backtracking. So first we will check if q plus 1 is equal to s of I. If it doesn't matches, we will do the backtracking with the help of the prefix function value, that is this one. Now if both are equal, if the string is equals to the pattern, in that case we keep on incrementing the pattern, right? We want to scan now next character. So now if q is equals to m, what is m? The length of the p. So if it is equal, then in that case what we will be doing is we will be printing the value of I minus m. And then how we find out the next match? We find out the next match with the help of the prefix function. So this is we will be when we reach the end of the pattern. So in that case what we are saying is q is equals to the prefix of q. So the last value from that particular last value, what we are doing is we will be finding the next match. So we can see that we have reached the last value, that is m position. So what is the pi value for that? That is 1. The prefix function value is 1. Now the pseudocode for the prefix function, so it comes out to be, it will be taking a time of m, because the size of this pattern is m, so it will be taking m because we want to calculate the prefix function for all the m values. Then here we want to scan all the string of till n, right? So it will be running n times. So here 1 2, for assigning the values it will be taking a constant time, but after that it will be for the loop is running till n times, so it will be taking order of n time. So total time taken by this algorithm is m plus n.